All right. So here we go. A rectangle is a quadrilateral with four what? Four what angles?
Right.
Yeah, four right angles. Four right angles. Okay? So, 641, if a quadrilateral is a rectangle, then it's a parallelogram. Okay, so every rectangle is a parallelogram. Alright? If it's a rectangle, then the diagonals are congruent. Okay? So a rectangle is a parallelogram, and its diagonals are congruent. Does that make sense? The rectangular gate has diagonal braces. It says, find each length. Alright, let's find each length. So it says HJ. HJ is this length. Well, if this is 48, then this is also 48. Then it says HK, that's this length here. Well, if this is 30.8 here, then this is 30.8 as well. So it makes the whole thing 61.6, and this whole thing is 61.6. Does that make sense to you guys? The diagonals bisect each other, which means this is equal to that. So they're both 30.8. And the diagonals are congruent, so this is equal to that. So I just do 30.8 plus 30.8 is 61.6, and that's how I get the whole length there. Any questions on that? Okay. Continuing on to the next page. A rhombus is a quadrilateral with four congruent sides. Good. So a rhombus has four congruent sides. Remember, if all the sides aren't the same, then you're on the wrong bus. Get it? Rhombus? Okay. Rhombuses are parallelograms. That means the opposite sides are parallel. If it's a rhombus, then the diagonals are perpendicular, which means they. Oh, let me close your please. Perpendicular means they meet at what kind of angle?
90 degrees.
90 degrees, or right angle, exactly. If it's a rhombus, then each diagonal bisects a pair of opposite angles. So the diagonals bisect the angles. That means 1 and 2 are congruent, 5 and 6 are congruent, 7 and 8 are congruent, 3 and 4 are congruent. Does that make sense to you guys? So what's an example of that? Let's take a look. Marcus, please. CF, this is a rhombus. Find CD. Well, all the sides are congruent, which means 5A equals 3A plus 17. Subtract 3A, I get 2A equals 17. Divide by 2. A equals 8.5. Very good. To find the side, I plug it back in there. 5 times 8.5 is 42.5. So each side is equal to 42.5. They're all the same. Okay? Now, it says find GCH, angle GCH. Let's see, GCH, that's this angle right here. If GCD is B plus 3, so this whole thing is B plus 3, and CDF, this whole thing here, is 6B minus 40. Okay, well, since this is a parallelogram, what do I know about the consecutive angles? This one and this one, are they congruent? No, they're what? Supplementary. Good, which means they add up to 180. B plus 3 plus 6b minus 40 equals 180. B plus 6b is 7b. 3 minus 40 is negative 37 equals 180. Add 37 to both sides. Equals 217. Remember, guys, you don't have to be writing all this stuff down if you don't want to. This is all going to be on YouTube. So you can write it down. You can write it down, but don't write it down at the expense of your understanding.
Yes, can I save it for like to do later?
Yeah, totally. Totally. That's why I gave you these packets. You know what I mean? So you could just be watching the video, writing down, you understand? So in your own studies on your own time. Because now is the time that you really need to be understanding what's happening. So I divide by 7. I get B equals 31. Cool. Well, if B equals 31, then this angle is 31 plus 3, which is 34. GCH is half of that because it gets bisected. So GCH is half of 34, which is 17 degrees. You see? That was a very complex problem. Why? I had these two angles. I was trying to find this angle. I had this angle and this angle. Well, I have to solve for B. Well, I do that by adding them together and setting them equal to 180. But once I solve for B, I can figure out that this angle is 34, then divide it by 2 to get that angle, which is 17.
So that angle, so angle C and D, they're supplementary?
Yeah.
Wait, are all the angles supplementary?
No. Consecutive angles in a parallelogram.
So then C and G would be congruent?
Supplementary. D and G would be congruent. C and F.
Yeah.
Opposite angles are congruent. Consecutive angles are supplementary.
And that's only for rhombus?
That's for any parallelogram. Good questions. All right, continuing on. All right. A square is quadrilateral with 4 right angles and 4 congruent sides. Square is a parallelogram that has properties of both a rectangle and a rhombus. Okay? So the square has properties of both a rectangle and a rhombus. All right. We're not going to do all of these. I'll just do the first one. Or let's just do okay. 18. If this is 61, these are right angles, so this has to be 29. Why? 90 minus 61 is 29. Okay, this is 90 degrees. This is 90 degrees.
Shouldn't one be 29?
That would be 29 exactly, because that's alternate interior angles, and that's 61 degrees. Okay? For this one here, okay, I know that this bisects, so 2 and 3 are both 45 degrees, because it would be 90, but they're cut in half. All of these, 4 is 45 degrees. 5 is 45 degrees. The diagonals meet, they're perpendicular, so 1 is the only one that's different. It's 90 degrees.
Wait, for 19, would 3 and 4 be 45 too?
No.
I mean 3 and 2. Oh wait, no, those add up to 90.
They add up to 90. You don't know exactly what they are because that's a rectangle, not a square. All right. Any questions on this? Sure. Okay. That's the end of that lesson. So just for context, that was the first lesson. All right. Conditions for special parallelograms. This basically just says the exact same thing as what we went over before. So it's the shorter part. Okay. If you've got a parallelogram and one of the angles is a right angle, then it's a rectangle. If the diagonals are congruent, then it's a rectangle. All right? For this, if I have a parallelogram and I have two consecutive sides that are congruent, then it's a rhombus. Okay? If the diagonals meet at a right angle, then it's a rhombus. And if the diagonal bisects the angles, it's a rhombus. Okay, so those are the conditions for it. Does that make sense to you guys? That's basically the exact same thing we said before, but just kind of doing it conversely. Saying, how do we know it's a rectangle? How do we know it's a rhombus? Well, if the diagonals are congruent, it's a rectangle. If the diagonals are perpendicular, it's a rhombus. You see that? Okay, next one. Lesson 6.6. Okay, properties of kites and trapezoids. Let's take a look at this one now. A kite is a quadrilateral with exactly two pairs of congruent sides. Two pairs of congruent sides. Alright, so let's take a look. So you see, that's a pair of congruent sides, that's a pair of congruent sides. They're not all the same. A rhombus is when all the sides are the same. A kite is when I have two pairs of congruent sides, but they're not all congruent. Does that make sense? Okay, if a quadrilateral is a kite, then its diagonals are perpendicular. Okay, so just like a rhombus, the diagonals are perpendicular, but in a kite, the difference is not all the sides are congruent. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. You see? These opposite angles are congruent, but these opposite angles are not congruent. You can kind of tell this angle is bigger than that angle, you see? Okay, so there you go. So those are the properties of kites. Now let's give an example. Okay, in kite EFGH, let me just make sure I'm recording. Good. In kite EFGH, FEG is 25 degrees. So FEG, that's this one right here, is 25 degrees. And FGJ, that's this one here, is 57 degrees. Okay, find each measure. G, F, J. Well, okay, you know this one here is 90. That means this one and this one have to add up to 90. So it's 90 minus 57 equals 33 degrees. So this one here is 33 degrees. Okay? Yes, sir. Sure. Guys, you should really, at this point now, in the reviews, water, bathroom, make sure, because you missed good stuff. JFE is this angle right here. Okay? Again, this I know is 90 because the diagonals are perpendicular. So these two have to add up to 90 degrees. So I do 90 minus 25 equals 65 degrees. There you go. GHE is this one. Well, I know that this angle here and this angle are congruent, so this one is just 65 plus 33 equals 98 degrees. The biggest thing with questions like this is you have to do it systematically. If you find yourself just reaching and trying to guess, then you're not going to get the right answer. The information is always right there in front of you. You just have to be able to find it. And the reality is, guys, as I was sitting here thinking, I was like, man, this is just a huge packet full of information, right? This is just a huge packet full of information. You know, how do I link it all together so it makes sense to your minds? Well, the thing is that the underlying thing with all of them is being able to look at a picture and say, what do I know and what do I need to know? You see? And then to be able to go from what you know to what you need to know. That's really the skill of geometry, where you're looking at something visually and then all the exact types of problems, they can change, but the actual skill in your mind is that looking at something visually, what do I know based on this image, and what do I need to know, and how do I get there? Does that make sense? Okay. Thank you, Subai. Okay. All right, let's take a look now at a trapezoid. Do you guys remember my trapezoid joke?
No.
Oh, you know it?
Can you repeat
It's
it?
the guy, he had a cage, he was a special hunter, and he had to build a special cage to be able to trapezoid. Okay. A trapezoid is a quadrilateral with exactly one pair of parallel sides. One pair of parallel sides. Each parallel side is called a base. Each non-parallel side is called a leg. Base angles are two consecutive angles whose common side is a base. You see the base angles here and here? If the legs are congruent, then it is an isosceles trapezoid. So if these two red legs are congruent, it's an isosceles trapezoid. Yes, sir.
Will this be in the exam, like blanks, and like you gotta fill it in?
I honestly don't know. But you have to know that. You have to know this information. Yep. Okay. Let's take a look at isosceles trapezoids specifically now. Okay. If it's an isosceles trapezoid, then each pair of base angles are congruent. See? The reds are congruent, blues are congruent. If trapezoid has one pair of congruent base angles, then it's isosceles. If a trapezoid is isosceles, if its diagonals are congruent. See? So isosceles trapezoid has congruent diagonals. And most of the time, just looking at a picture, you'll be able to determine that anyway. So that's the point. It's just trying to get to a place where you're like, yep, I could do that. All right, let's look at an example. It says find the measure of angle y. Well, I know that this angle is the same as this angle, which is 117. Cool. Well, I know that these angles are supplementary. The opposite angles are supplementary in an isosceles trapezoid. Okay? So, all I have to do to get the measure of angle y is do 180 minus 117. I get 63 degrees. Simple as that. Now it says RT equals 24.1. Okay, that's that one. QP equals 9.6. Now RT is this whole thing, not just part of it. It says find PS. Well, this part PS is plus this part QP equals the whole thing. You see? So QP plus PS is equal to RT. Well, QP is 9.6. PS is what we're trying to find. RT is 24.1, so I just subtract. And I get PS equals 14.5. Any questions on that? All right. Next. We're not going to do this one.
Those two are congruent.
They should be congruent. Yep. Mm-hmm.
We use
Oh, I guess, yeah, we could do it. Look,
You set them equal, right?
if they're congruent, you just set them equal, right? So you get 2y squared minus 25 equals y squared plus 24. You subtract y squared from both sides. You get y squared minus 25 equals 24. Add 25 to both sides. You get y squared equals 49. Take the square root of both sides, and you get y equals negative 7 or positive 7. Because it's plus or minus. And it doesn't matter, because no matter which one you plug in there, you'll get the same thing. Okay? Does that make sense? All right. All right, next one. JL equals 5z plus 3, so that's this one. KM equals 9z minus 12. Those are my initials. What do I do? What do I know about diagonals of a trapezoid?
congruent.
They're congruent, so I set them equal. Do some quick algebra. I end up with 15 equals 4z. Okay, divide by 4. Z equals 3.75. Okay, I skipped some steps now. You guys know how to do that at this point. Any questions? All right. All right, mid-segment of a trapezoid. Mid-segment of a trapezoid is a segment whose endpoints are the midpoints of the legs. Okay. So, I know that this is the average of these two. The length of the mid-segment, so make sure you're paying attention. The length of, you asleep yourself? I'm sorry, Priscilla. Good morning.
What?
Okay. The mid segment is the average of these two. So guys, pay attention. Look, the best way to figure this out, is if I have the middle one and one of the sides, I just see the difference. To get from 38 to 31, I subtract 7. So to get from 31 to the next one, I'd subtract 7 again, and I'd get 24. Does that make sense?
Mm-hmm.
You see? But what if I had those two sides and not the middle one? Well, then I would just do 24 plus 38 over 2. I'd get the average, and I'd get that that's 31. You see? Does that make sense? So if they give you the middle, then you just find the difference, and you just keep going. You go one more step. If they don't give you the middle, you just take the average. And that's how you get it. Any questions? All right. So that's the end of 6.6. Let's go to 7.1.
We can do the chapter test.
That's on you guys, if you want to do that. Okay.
Should we swim the catch together?
Can you start super fast?
Yeah, sure. Okay. Figures that are similar have the same shape, but not necessarily the same size. So now we're getting into similar figures. Okay? So and the ratios of the sides are the same. Okay? So a similarity ratio is the ratio of the lengths of corresponding sides. Of two similar polygons. So an example of corresponding sides is like, if I look at this one, 6 corresponds to 12. 5.4 corresponds to 10.8. Do you understand? It's like the same side of the polygon for each of them. Does that make sense? Okay. And sometimes they're rotated, which can make it challenging. But for this one, the similarity ratio of ABC to DEF is 1/2. Because this one is half the size of this one. If I go the other direction, from DEF to ABC, it's 2, because this one is double that one. Okay. So how do we find the similarity ratio? Well, we check all the sides. Okay. So the way to figure it out is to kind of rotate it to get to a point. You see, this angle corresponds to that one corresponds to that one. So 60 corresponds to 24. So I'll do 60 divided by 24 to find the similarity ratio, which is 2.5. Then I'll do the other side here, which is 45 over 18. And I'll see if that stays the same. 45 over 18 is 2.5, so it looks good so far. And finally, the hypotenuse is 75 over 30, which again is 2.5. So they all have the same similarity ratio. Does that make sense? Okay. Does this make sense to you guys? To find the similarity ratio, you just take one side divided by the other. That gives you the similarity ratio. All right. Now, moving forward, that was lesson 7.1. I think I skipped 7.2 for some reason. So let me check in the book real quick. I guess I just didn't make one for that one. What was that? No. I'm pulling from all the ones that I've made for you guys. You see? So I guess I just didn't make one for you guys for that lesson. But I don't want to just skip it. Alright, I want to check before I just skip it. Okay, shh. Oh, I guess we didn't do this lesson. Oh, it's dilation. So look. Look. So this one, if I wanted to apply a dilation, look. If I've got these points x, y, and I want to apply a dilation 3x, 3y, then I just take all the points and I multiply the x by 3 and the y by 3. See, so 2 times 3 is 6, 4 times 3 is 12, 5 times 3 is 15, 4 times 3 is 12, and so on and so forth. You see that? So applying dilations, all I do is multiply the coordinates of the point and draw the new shape. Okay? All right. So now we can go on to lesson 7.3. Okay. This is angle-angle similarity. Now, if I know that two angles of two triangles are congruent, two pairs of angles are congruent, then I know that the third must be congruent because they all have to add up to 180. So if two are the same, then I know the third has to be the same. And if all three angles of a triangle are congruent, then I know that they're similar because they're the same exact shape. If the angles are the same, then the shape is the same. Does that make sense to you guys? Okay, so they're similar. So what that means is all I need to know is that two angles are congruent, two pairs of angles are congruent, and I know they're similar. That's what the angle-angle similarity postulate says. So, for instance, this one, it doesn't seem obvious that two angles are the same because look, one is 43, the other is 47. But I know that this angle and this angle have to add up to 90 because that one's 90 degrees. Well, 43 plus 47 is 90 degrees. So in fact, they are the same. You see? Since all the angles are the same, they're similar. And I know that by the angle-angle similarity postulate. God bless you. Okay? The angle-angle similarity postulate tells me that they're similar. Any questions on that? You can do it, Marcus. The next one is an obvious one. Side, side, side similarity. If all the sides are proportionate, then they're similar. That means if this one is double this one, and that's double that, and that's double that, then they're similar, because all the sides are proportionate. Okay, so that gives an example right here. You've got 4, 4, and 6, 6, 6, and 9. You see? He divides them all. 4 divided by 6 is 2/3. 4 divided by 6 is 2/3. 6 divided by 9 is 2/3. There you go. They all have the same ratio, which means that those two triangles are proportionate, or similar rather. All right. Next is side angle side similarity. Okay. Side angle side similarity. So, you guys remember this? Angle, angle, side angle, side, side angle, side. Okay, so look. Side angle side. All I have to do is show that I've got two sides that are proportionate. So 12 over 16, 15 over 20, and this angle has to be proportionate. So let's take a look. Let's take a look at these two examples for side angle side. Okay. Here, this is 2, and in the big triangle it's 6. So it would be 2 over 6, which is 1/3. This is 3, and in the big triangle it's 9, so it's 3 over 9, which is 1/3. So those two sides are proportionate, and then look, this angle here is the same for both. So it's side angle side. You see that? Does that make sense? Here, I know this angle is the same as this angle because they're vertical. 12 over 16, I'm going to try this side and that side. I divide by 4, and this becomes 3 over 4. Then I have 15 over 20. I divide by 5, and I get 3 over 4 again. So they have the same ratio, so these two triangles are similar by side angle side. Does that make sense to you guys? Okay. So that's the next example. Okay, now we get into finding lengths. Okay, so finding lengths. Here's a good example. Let's take a look. Okay, I know these two are similar because of angle-angle similarity. Look, this angle is the same for both triangles. That angle is the same for both triangles. So therefore, they're similar by angle-angle similarity. It now wants us to find RT, which is the distance from here to here. Okay, well, I know that the ratios have to be the same. So 8 over 12, the small over the big, equals 10 over RT. Does that make sense? You guys got that? Well, now to solve, I just cross multiply. I get 8 RT equals 12 times 10, which is 120. And then I divide by 8. I get RT equals 15. And I'm done. Any questions on that? Okay.
Are we done?
Marcus,
I actually feel so bad right now.
I understand, but let's focus, please, for the sake of yourself, for the sake of your teacher, and for the sake of your classmates. We'll talk. I don't know if we're going to be able to. We got to focus. All right, 7.4, applying properties of similar triangles. All right, look. If I have a parallel line, you see? A line that's parallel to one of the sides, then it divides the sides proportionally, you see? green. I'll separate them both to green over blue. So green over blue equals green over blue, and the answer is proportionally. Okay. So if I have a parallel line like that, it binds the sides this over that equals this over that. Okay? What's an example of that? Well, it gives you an example right here. Okay, so you can take a look at that on your own. But here's an example right here. Okay, I've got a parallel line. So this is my green part. This is my blue part. It asks for Pn, so I'll call that x. So x over 3 equals 5 over 2. Multiply both sides by 3. And I get x equals 5 times 3 is 15 over 2, or x equals 7.5. I don't have to cross multiply because x is on the top. I only cross multiply when x is on the bottom. Does that make sense? Since x is on the top, I just multiply by the denominator on both sides, and I get x by itself. All right. Okay. So next, triangle angle bisector theorem says, look, that if I bisect an angle, you see this? If I bisect an angle, then BD over DC, so the ratio of this to this equals the ratio of this to that. So this over that equals this over that. See? So let's give an example. Number 4. Okay, so this is the green and the green and the blue and the blue. Okay, so green over blue equals green over blue, or blue over green equals blue over green. So y minus 2 over 8 equals y over 2 divided by 4.5. Okay? And I can cross multiply here to make my life a little easier. And I get 4.5 times y minus 2 equals 8 times y over 2. Distribute that in, it becomes 4.5y minus 4.5 times 2 is 9 equals 8 divided by 2 is 4, so it's 4y. Okay, I subtract 4.5y from both sides, and I get negative 9 equals negative 0.5y. I then divide both sides by negative 0.5. And dividing by 0.5, it's negative over negative, so it makes it positive. Dividing by 0.5 is the same thing as multiplying by 2, so y equals 18. Okay, the algebra was kind of tough on that one, but the property is simple. It's just, if I have an angle bisector, it divides this segment proportionate to each side. So blue over green equals blue over green. God bless you. And if you want to bring colored pencils, I highly suggest that you do, because it can help you just to understand the material. Any questions on this one?
Yeah.
All right. Remember, this is all being recorded so you can go back. 2 more lessons. All right.
Phew. I'll be back.
Bless you.
God bless you. God bless you. Okay. So let's take a look at this. All right, this is where we actually start to use this stuff. Okay? All right, so these two triangles are proportionate. He's 5 feet 6 inches. This is 5 feet, so that's 60 inches in total. That's 66 inches. I have to convert so they're all in the same units. 12 times 14 is 168, plus 2 is 170 inches, and they're trying to find the height. Well, this over this equals this over this, so h over 66 equals 170 over 60. I multiply both sides by 66, and I get h equals 170 times 66 divided by 60 is, 170 times 66 divided by 60 is 187. Please. Okay, I divide by 12. 187 divided by 12 is 15.583. So it's 187 inches. 15 times 12 is 180. So it's 15 feet. And then there's 7 inches left over. Okay?
Wait.
Don't worry about that. All right. Questions on this one? What made this tough was converting the units. Okay. Okay. A scale drawing represents an object as smaller than or larger than its actual size.
Small.
Okay? So let's take a look. Don't worry about this blank. Drawings. Scale. Oh, it's scale. Is the ratio of any length in the drawing to the corresponding actual length. Okay, drawing of a patio has the dimensions shown. The patio is actually 10 feet wide. What's the length? Okay, so they're proportionate. So if this is 10 feet, and that's 4 inches, this is 7 inches, that's x. I do x over 7 equals 10 over 4. I multiply both sides by 7. I get x equals 70 over 4, which is 17.5. So it's 17.5 feet. You see that? It's just proportions. Again, it's just proportions, whether you have the picture or not. So it's 10 feet divided by 4. The drawing is 7 inches long, so it's x over 7 equals 10 over 4. Any questions on that? Okay. Next. So there's just a couple other examples. I'm not going to go through those for the sake of time. Now, perimeter ratio and area ratio. Okay, if the similarity ratio is 1/2, the perimeter ratio is the same. So if the sides are half, if one shape has sides that are half as long as the other shape, then the perimeter is half as long as the other. Marcus, no.
No.
No. So then the perimeter has the same ratio. But the area of one shape, so you see, look, this side is half of this side, so the perimeter of this is half the perimeter of this. But the area of this isn't 1/2, it's 1/2 squared. Okay, so it's not the same similarity ratio, same as similarity ratio, it's the similarity ratio squared. So if this is half of that side, then the area is 1/2 squared, or 1/4 of that area. All right. So let's give an example of this. Okay. So you have the similarity ratio is clearly 3. 12 over 4 is 3. So the perimeter is 42. So the perimeter of the other one is 42 times 3, which is 126. But the area Oh, I'm sorry. The perimeter was 42 of the bigger one, so I divide it by 3 and I get the perimeter of the smaller one is 14. You see? It's because it's saying for DEF. The area is 96, but I don't divide by 3, I divide by 3 squared. So it's 96 over 9 to get the area of the smaller one, which is 10.6 repeating.
Why do you divide by 3 squared?
Because the area ratio is the similarity ratio squared. Does that make sense? All right. So that's it for that one. And then finally we have lesson 7.6. Okay. Thank God this is one of the easier ones. Okay. A blank, a dilation, is a transformation that changes the size of a figure but not its shape. A dilation ratio or a scale, basically. I don't remember what goes in that blank. Oh, the scale factor, sorry. A scale factor describes how much the figure is enlarged or reduced. All right, so you take a look at these two triangles, right? All right, this is 2, that's 4. What's the scale factor? 2. It's double, right? If this is 3, what should D be at? 60. Does that make sense? Simple as that. Okay, so we take a look at this one here. Okay, it gives us the location of the points. -15, 0. M is -10, 0. Q is -30, or 0, -30, and it asks us for N. Well, how do I do it? I do 10 over 15 equals this, which is X over 30. You see? And just multiply by 30. And I get 300 over 15 is 20. So there you go. 0, -20. Does that make sense? Any questions on those? Okay. We have accomplished all that we set out to do today. If I were you guys, I would review the video that I will put up today on YouTube and make sure you understand everything in your packet. Good job today, class.